one of Mill-Turn webinar series. We will talk today about working on a part on 2 spindles, and I will show you how we use the synchronization interface to synchronize operations, to reorder them, and to create a loop in the machine process. And I'm talking about working with one turret on one spindle, on main spindle, for example, and with the other turret on the back spindle in the same time. I choose for today a part which is a turning tool created by Iskar, and it's an integrated tool and holder, HSK A63, and on this holder we only mount the insert. So I will use for today the last version that is available, 2015, Series Spec 2, Hotfix 4, released 2 days ago. And let's start that. For today I already prepare all the operations because it takes time and we cannot do everything in 15 minutes in 1 hour webinar. So I already prepared the part and I will start describe you what I did here. This is the part, and I start with okay, I will present you the machine also. It's a DMG Mori NT 5400 with a B-axis, a rotary turret, a standard machine with 2 spindles, main and back spindle. We can close this and continue to our operation. So I will start with the turning mode, and a long operation, long turning, and it's rough and finish. We talk about this. I'm trying to do less operations, and I'm not using 2 tools, one for rough and one for finish. And I continue with a grooving tool to remove the material. After this, and I'm working with lower turret. I'm starting to work with lower turret, turning, and continuing with upper turret. Now, between them, I always use machine control, as we already know. I'm sending the devices, the turret, to a safety position, and I continue with upper turret to create several machining operations to remove the material, rough, and finish profiles. So I have here on this face an machining using a 20mm end mill, and I will have here to remove all this material on this side, also on machining, and right after that the finish operation for the walls. Again, machining on this position to remove everything around part on those surfaces. Again, a finish operation, and using again the machine control to send the turret to a safety position because I'm changing to lower turret. And the reason I do this is only to show you that even if we have a lower turret without y-axis, which this machine have a lower turret without y-axis, we can use fourth axis, c-axis, in order to create operations. And I can create machining, the profiles, I can drill any milling operation. on face or on radial. I'm machining operation to remove here the material from these surfaces, and here we will have some rest material. Finish again. Another small profile here to remove a corner. We will see that in the Solid Verify in machine simulation. I'm finishing to work with the lower turret, and again using machine control to send it to safety position. I continue to work now with turret, upper turret on the main spindle, and I have here a small profile to mill this surface to remove the material, and I have a drill. Now we are here where the insert in the place that the insert should be mounted. So I will drill first in this corner to make easier for the milling operation, die machining operation, to remove the material, and finish on the walls. One profile operation here to remove this material in this place. Again, I'm using eye machining for this pocket, and finish on the walls. Also for opposite pocket, 180 degrees. I didn't transform this operation because dimensions of this pocket are different. So I create a new position and a new operation, also with finish. And we have here also a small pocket which I cut with a profile, with helical, with a bull mill with small radius on the corner. Machine control, I will retrieve the turret, and I need to transfer the part to the other spindle. Now working with lower turret on back spindle, I'm also starting with turning on the face and turning long process, long rough and finish, using a helical profile to remove all the material inside here, inside this, and also on these slots a contour to remove the material here, and on opposite side a drill, and I use here drill around 4 axis because I'm continuing to work with lower turret which don't have a y-axis, and I will finish with the turret retract. So this is what I choose to do. It's not maybe the perfect technology, but with this technology I can show you in a very short description what we can do. So let's simulate and see how it's working. Machine simulation will calculate the tool pass. And for now, we have the first strategy, the standard strategy, starting to work on main spindle, moving the part, transferring the part to the back spindle, and continuing to work. Let's make the stock transparent. This is the way I like. And simulation, stop, move. As I say, we start with the turning, removing all the material, and continuing with the grooving tool, turret going to a safety position, retract, and we start working with upper turret, eye machining, removing all this material on this side. I will increase the speed. Of course, you can see the fixture, the realistic fixture, which I designed in SolidWorks. Very easy, and mount them in the setup. Next tool is going to remove the material from this side. And finish. Next operation is a finish on the wall. Now we have here material that we want to remove also, and finish on the wall. Upper turret is retracted to the safe position, and we are doing again with an eye machining with lower turret and 4 axis. Of course, if I were now I was now on the machine, I wasn't use the lower turret for milling, because I will always have less speed on lower turret on spin rotation, so it's preferred to work with upper turret. But for the demonstration, I am doing this. Using 4 axis and finish. Also here, a small rest material that we have, a small corner after previous operations. I will remove it with profile and retract again. This corner will be cut now. I'm going manual because it's a very short operation. Yes, we remove all the material also on this corner. A drill before the eye machining operation in the corner, and with a small tool, a 4mm tool, we remove all the material here in the insert mounting position, and finish. Going also manual. Here also a small profile operation to remove this cut. And I'm machining on the pockets with a helical entry, and finish. The same on opposite side, and finish. A 6mm end mill, bull mill with a corner radius, because this is what I have here on the part. Profile, helical, and I remove all the material. So this is the part after working on main spindle. Remove all material around. Going to transfer process, defining eye machining, preparing C-axis on 0 degrees, also on back spindle. Taking the part and going to reference. Continuing to work with lower turret. We start with a turning operation on face. Now I'm using, as I said, a 20mm end mill to remove the material inside the helical contour with 4th axis. And a 12 millimeter end bull mill with 1.4 millimeter radius to remove the material on these slots. Again with 4th axis. I'm going manual. The last operation is a drill around 4 axis, here and also on 180 degrees. Going to 180 degrees, and we finished turret retracted. This is the part with the standard strategy. Let's hide the fixture for a moment. Fixture, hide. Okay, so this is the part. Let's hide also the part and see only the stock. So it's finished around. Now let's see how and what we need to do in order to see the part on both spindles and to synchronize them. First, let's look at the machining time. With standard CAM3 synchronization, we have a 20 minutes and 27 seconds total machining cut time. Now I will copy the part because I want to change, to do some change. So I will save as a copy. I already have a copy from the previous webinar, so I will change the name, 3. And on this new part, I want to do several changes. First, let's go back to turret synchronization. How can I make this total machining cutting time shorter? I see that lower turret operation on back spindle, here, this group of operations, I can work in the same time when upper turret is working on main spindle. So I have this group here, and I can synchronize them with this group here. Upper turret working on main spindle, lower turret working on back spindle. I can save time. Okay, so I will go back to a country, and I will take all these operations from here, cut, move them, remove them here, paste. Okay, I need to recalculate 2 turning operations. And now I'm going back to turret synchronization. Delete all the synchronizations, create again by the new country order. And now I have the possibility to, this is the first operation on lower turret working on back spindle. So I want to synchronize it with this operation, upper turret on main spindle. I will delete this active synchronization. Now I select this operation and this operation on opposite channel, and I see synchronize them as start to start together. I'm already see here the total machining cut time decreased by 5 minutes. It's 25% from previous machining time. So I already save a lot of time. And we are ready to go, creating the G codes into the machine and cut the part. But now I want to simulate this. And in order to simulate, I will need to suppress my machine controls, because we have an issue here which we didn't solve yet, but is on the way to be solved on the next version. And I will explain you why we have this issue and how we are going to solve it, because it's important for you to know how to handle this kind of situations. Machines with cross-control options, meaning option to control a device from an opposite channel. I'm in an upper channel, and I want to control the lower channel and send some commands. It's not important if it's a movement command or a coolant or a spin command. Any command that I will send to lower turret from the opposite channel is cross-control named. Some machines have this, some machines don't have it, so it's different from machine to machine. Now, on machines that we have cross-control, user have freedom to do whatever he want to do, but not always is legal. Let's see here in machine control operation 3, I have a turret retract, lower turret. Let's go again to turret synchronization. And I'm talking about this job, for example. Here, I can add a movement of upper turret. It's on the machine, it's an option on the controller. I can do this, but it's not legal to do this because I'm sending the command to upper turret in the time that upper turret is working. If I'm going to time frame view, let's zoom in to see all the operations. Okay, I'm going to this machine control operation here, and if I send here a command to upper turret to do something, maybe a movement, maybe a retract, maybe a spin command, a coolant command, an air command, anything, it's not legal in this situation here because it's still working. It's in the middle of another operation. So we are going to solve this problem in this way. Any action, today we have several actions here. Lower turret is going to a safe position, and upper turret, let's say I'm sending a dwell command. Hey, wait for 5 seconds or move to a different position. It's impossible because the upper turret is working, we already know. But what happened if in the turret synchronization I will divide this operation into small operations? Each action can be synchronized, and this is the way that we want to solve the problem. Each action we will be able to see in turret synchronization interface and synchronize. So if I send a command to upper turret, I will see this command, this action in turret synchronization. Exit without saving. Yes. I will see this command here again of movement of turret, which I command here in this channel, I will see as a command in this channel. So a machine control operation will be divided to actions, and I will be able to synchronize them, which should solve our problem. Now, for now, I will just suppress the operations, the machine control. I don't want to delete them because I need them in the G code. And I'm going to turret synchronization again. Delete, synchronize again. I don't have any machine control. This operation, delete the synchronization and synchronize with operation number 3 as before. Okay, now I can simulate. I also press this button, show target on second table. This is very important because when we press this button in machine simulation, we will scan the CAM tree. All the operation that we do on main spindle, we will remove the material from the stock and show the part on the back spindle. And you will see that now. One moment and we're ready to run. Okay, let's move this window. As I said before, all operations that we done on main spindle, we remove the material and we show the part on the back spindle. Let's hide the fixture for a moment again. Table 2 fixture hide. So this is the part after all main spindle operations. Show fixture again, and let's start working. Let's position this. So as we define entire synchronization interface, we will start with lower turret 2 turning operations here on main spindle. And with the grooving tool. And now they will start working together, upper turret working on main spindle and lower turret working on back spindle, synchronized. Let's increase the speed. Oh, just a second, my mouse go crazy. Okay, continue. This turret is in a turning operation. This turret, eye machining, milling, everyone works, is doing his job. And we save machining time on this part. Continue. Drilling on back spindle. And back spindle finished his work here. Upper turret can continue to work to finish his job. Okay, and finish here also. Finish again. That's all operation that we see in previous. Now, lower turret finished up his job on the um, small pocket with finish on the opposite side. And from main spindle and back to the reference. On main spindle, I also need to load a new stock. So maybe a bar feeder can be used or an external robot. This process can be done also at the end of in the start of the program. I finish here, and when I press the next start, I will start the program with MCO, with the ejection of the part with the part catcher, transferring the active stock and loading a new one. So it is a user choice how he wants to define this loop, this cycle. The load-unload process at the end or at start, there is no difference. But when we start cutting, it's important that we have two parts on the machine. One after on the back spindle after all operations on main spindle, and on main spindle a new stock. If I press refresh, this is the situation that I need when I start cutting. So this is all. Now we are going back. We did the simulation, everything was okay. I'm just going to unsuppress the machine controls because I did this only as a temporary solution for now to simulate, unsuppress. I'm going to synchronize them again. Synchronize again, and this operation with this start. Now I'm ready to generate the G-code and send it to the machine. Now this is the process. This is how SolidCAM handles twin turret, twin spindle machine, and creating a loop, creating a cycle for a mass production. We are continuing to develop new and to improve those options. We have a lot of ideas how to improve the synchronization interface for the future. Every day we add a new option, a new function. We will be able to synchronize in the future also actions in the operation, a tool change for this operation that can be synchronized, the start of tool pass, the end of tool pass. We are continuing to develop and improve this tire synchronization interface because it's a very important tool that helps us to generate a better technology and a short machining time, machining cut time. That's all for today. I'm just looking now for the questions. No question for today. Thank you, everybody, and see you in our next webinars.